Recent research is increasingly revealing that insulin resistance, a hallmark of metabolic dysfunction and a precursor to type 2 diabetes, is not solely dictated by genetics or total caloric intake, but is profoundly influenced by the gut microbiome. Clinical trials and dietary interventions now highlight how gut-derived compounds, particularly those produced by microbial fermentation, can either exacerbate or ameliorate insulin sensitivity. These studies underscore the notion that what we feed our microbiome is just as important as what we feed ourselves, demonstrating that targeted dietary strategies can reshape microbial metabolism in ways that support long-term metabolic health. One of the central mechanisms connecting gut microbes to insulin resistance involves short-chain fatty acids, SCFAs, such as butyrate, propionate, and acetate. These metabolites are produced when beneficial bacteria ferment dietary fibers and resistant starches that reach the colon intact. Clinical trials have shown that higher SCFA levels correlate with improved insulin sensitivity, reduced hepatic glucose production, and enhanced peripheral glucose uptake. For example, individuals who consume diets rich in legumes, whole grains, and nuts, foods high in fermentable fibers, experienced measurable improvements in fasting glucose and postprandial insulin responses. The production of SCFAs also helps maintain gut barrier integrity, preventing endotoxins like lipopolysaccharides, LPS, from entering circulation. When LPS levels are elevated, they trigger systemic low-grade inflammation, which can impair insulin signaling in tissues like muscle, liver, and adipose tissue. By increasing SCFA output, gut microbes help reduce this inflammatory burden, thereby protecting insulin sensitivity. Conversely, clinical studies have also revealed that diets high in refined carbohydrates, saturated fats, and ultra-processed foods can shift the gut microbiome toward less beneficial taxa, increasing the production of metabolites that promote inflammation and insulin resistance. Certain gut bacteria can metabolize choline and carnitine from animal-based and highly processed foods into trimethylamine, TMA, which is converted by the liver into trimethylamine N-oxide, TMAO. Elevated TMAO levels are associated with systemic inflammation, endothelial dysfunction, and impaired insulin signaling. These findings highlight the powerful influence of dietary choices on microbial metabolism. The same macronutrients can lead to either protective or harmful metabolite profiles depending on the quality and source of the food. Recent dietary trials have begun to test targeted interventions to improve insulin sensitivity through microbiome modulation. For instance, randomized studies have explored high-fiber diets incorporating legumes, whole grains, and nuts, finding that participants experienced not only improved fasting and postprandial glucose levels, but also shifts in microbial composition toward SCFA-producing species, such as Faecalibacterium prosnitzii, Roseburia, and Bifidobacterium. These microbial changes coincided with reductions in inflammatory markers like C-reactive protein, CRP, and interleukin-6, IL-6, demonstrating a direct connection between microbial metabolism, inflammation control, and insulin sensitivity. Other trials have explored prebiotic supplementation, including inulin-type fibers and resistant starches, which also promoted SCFA production and improved glucose handling, further emphasizing the tangible benefits of feeding the microbiome with fermentable substrates. Polyphenol-rich foods have also emerged as important modulators in these clinical studies. Foods such as berries, green tea, cocoa, and pistachios provide bioactive compounds that selectively enhance beneficial microbial populations while inhibiting less favorable taxa. The resulting metabolites, including SCFAs, flavonoid-derived phenolics, and secondary bile acids, improve insulin signaling, reduce oxidative stress, and support lipid metabolism. This demonstrates that insulin sensitivity can be improved not just through macronutrient composition but also via micronutrient and phytonutrient-driven modulation of microbial function. Timing and pattern of food intake appear to interact with these microbial effects as well. Clinical trials incorporating evening consumption of fiber-rich snacks, such as nuts, showed that they enhanced SCFA production overnight, improved fasting glucose in the morning, and reduced insulin spikes compared with carbohydrate-based snacks. This aligns with emerging understanding of microbial circadian rhythms. By providing substrates when the gut microbes are metabolically active, we can optimize SCFA output and strengthen metabolic signaling at critical times, further supporting insulin sensitivity. The implications of these findings are profound for individuals at risk for insulin resistance or type 2 diabetes. Rather than focusing solely on caloric restriction or macronutrient ratios, dietary strategies that nurture the gut microbiome can produce systemic benefits by reducing inflammatory metabolites, enhancing SCFA production, and stabilizing glucose and insulin responses. Even modest dietary changes, such as incorporating more legumes, whole grains, nuts, fiber-rich vegetables, and polyphenol-containing foods, can shift microbial communities in a favorable direction, supporting metabolic resilience. In essence, the emerging clinical evidence paints a compelling picture. The gut microbiome functions as a metabolic gatekeeper, translating dietary inputs into metabolites that can either impair or enhance insulin sensitivity. SCFA-producing bacteria act as protective mediators, reducing inflammation and improving glucose regulation, while dysbiotic shifts toward pro-inflammatory, metabolite-producing taxa can accelerate insulin resistance. By intentionally shaping the gut environment through high-fiber, polyphenol-rich, plant-forward diets, we can harness microbial metabolism to improve insulin sensitivity, support metabolic health, and reduce the risk of type 2 diabetes. These insights position the gut microbiome not as a passive observer, but as an active participant in metabolic regulation, and they highlight diet as a powerful tool to optimize systemic health from the inside out.